Have you ever noticed something strange? We live in a world powered by quantum physics, but almost nobody learns it in school. Your phone, your computer, lasers, MRI scanners, even modern cryptography, all of this exists because of quantum mechanics. And yet, in class, we spend most of our time pushing boxes down frictionless ramps and calculating how long a ball takes to fall. Why are we stuck in the physics of the 17th century, while the 21st century runs on quantum? If this already sounds weird, stay with this video until the end, because the answer says a lot about how education works and about how reality itself is stranger than you were ever told. Welcome to Archivistech, where technology, science, and human curiosity collide. If you like stories that connect everyday life with the invisible rules of the universe, consider subscribing and turning on notifications so you don't miss the next episode. Let's start with something simple. What does a typical high school physics class look like? Most curricula focus on what is called classical physics: Newton's laws, motion, forces, energy, basic electricity and magnetism, waves, maybe a bit of optics and thermodynamics. This isn't an accident. Classical physics is the historical foundation of the field. It explains planets orbiting the sun, bridges standing up, cars accelerating, and most of the machines we see around us. It's also much easier to teach. You can draw it, you can see it, and you can demonstrate it in the classroom with balls, carts, springs, and circuits. It builds students' intuition in a world they can touch. But here is the twist. The universe doesn't actually run on classical rules at the deepest level. Underneath everything is the quantum world, and it behaves nothing like those simple classroom diagrams. So why not just teach quantum mechanics early? One brutal reason: the math. Real quantum physics is written in the language of calculus, complex numbers, and linear algebra, things many students only see at university, if ever. The core of quantum theory lives in abstract objects like wave functions and vectors in a high-dimensional Hilbert space. You don't just track the position of a ball, you track probability, amplitudes, and operators. Imagine trying to explain a 4K movie to someone who only knows pixel art. You can give them the idea, but the full detail would be overwhelming. That's what happens if you drop full-blown quantum equations into a high school classroom. Many physics educators argue that before you can appreciate how quantum breaks the old rules, you need a rock-solid understanding of those old rules, classical mechanics and basic math. Quick question for you. Would you have liked to see quantum concepts in school, even without all the heavy math? Tell me in the comments, yes or no, and why. But the math isn't the only problem. There's also the system. Curricula are slow to change. Many programs were designed decades ago, when modern physics was still seen as advanced material reserved for specialists. On top of that, a lot of high school teachers were never deeply trained in quantum mechanics. Some may have had just 1 or 2 university courses on it, often very theoretical. Designing clear, accurate lessons for teenagers without oversimplifying or spreading misconceptions is not easy. Then there's time. Many schools struggle to cover even the basics of classical physics in 1 year. Some don't fully explore electromagnetism, which is already more directly relatable to everyday life. If they can't finish the old topics, adding quantum often feels impossible. So the system settles for a compromise. Mention a few quantum buzzwords like photons, energy levels, or the photoelectric effect, but avoid the deep, weird stuff. There's also a psychological barrier. Quantum physics is hard to picture. We love to imagine things. In classical physics, it's easy. A ball, a ramp, a force. But quantum objects are both waves and particles, spread out and yet detected at single points. They can be entangled, influencing each other instantly over huge distances, in ways that defy our everyday logic. Students and adults often use mental models based on images, what they can draw or imagine. Quantum asks you to let go of those simple pictures and instead accept abstract rules that are tested by experiments, but don't match common sense. In other words, the universe at the smallest scale is not designed to be intuitive for brains that evolved to throw rocks and run from predators. If your school never even told you that, it's not your fault. Here's the crazy part. While schools mostly avoid quantum physics, our entire modern world depends on it. Semiconductors, transistors, LEDs, lasers, solar panels, atomic clocks, MRI machines, even the GPS satellites that guide your maps. All of these work because engineers use quantum principles behind the scenes. And we are now entering the era of quantum technology. Quantum computers that could solve certain problems dramatically faster. Quantum cryptography that promises unbreakable codes. Quantum sensors that can detect tiny changes in gravity or magnetic fields. So we live inside a quantum civilization, but are taught almost nothing about the quantum rules that shape it. That gap between school reality and real-world technology is exactly why channels like Archivist Tech exist. If you're still watching, you're probably part of the small percentage of people who actually want to understand the rules behind the magic, and that already sets you apart. Some educators are experimenting with a new approach, teaching quantum concepts conceptually, without heavy math. Simple experiments, like the double-slit experiment, energy levels in atoms, and basic ideas of superposition and entanglement can be introduced in story form, simulations, and visual demos. Research suggests that, if done carefully, students can grasp the key ideas at a high level even before they master the full mathematical machinery. It won't replace classical physics. That foundation is still essential, but it could help a new generation see reality closer to how modern science actually understands it. So why don't we study quantum physics in school? Because the math is tough, the system is slow, teachers and time are limited, and our human intuition isn't built for the quantum world. But that doesn't mean you have to wait for the system to change. You can start your own quantum journey right now. If this episode sparked your curiosity, hit like so the algorithm knows this topic matters. Subscribe to Archivist Tech, and turn on the bell so you don't miss the next deep dive. Tell me in the comments, what confuses you the most about quantum physics, superposition, entanglement, or something else? Your question might become a future video. Thanks for watching Archivist Tech, and remember, the universe is way stranger and way more beautiful than your textbook ever told you.